Hello. Streaming. Having a code. 2023, day 8 and day 9. So, didn't do day 8 on time, so gave myself about an hour and a half. Ever the optimist to get day 8 done before we get to day 9. So, let's start set up day 8 and 9. So, copy paste day 8. How did that resume? Anyway, day 8. I don't know. I guess we can keep all that stuff. Parts 1 and 2. Put in a 0. Let's copy day 8 to day 9 while we're at it. Main, we'll put day 8 and day 9. Let's copy this. Put 8 here. And then a 9. 9. All right, so we need a day 8 dot input, and we need a day 9 dot input. Okay, tests. Mod day 8 and mod day 9. Let's take the tests from day 7 and copy paste them. Hold on. Day 8. Okay. Let's not assume anything about the solution. All right. Make a placeholder for day 9. Okay, back to tests. Okay, so we're all good. All right. Let's go read about day 8. Haunted Wasteland. You're still riding a camel across Desert Island when you spot a sandstorm quickly approaching. When you turn to warn the elf, she disappears before your eyes. To be fair, she had just finished warning you about ghosts a few minutes ago. One of the camel's pouches is labeled maps. Sure enough, it's full of documents, your puzzle input, about how to navigate the desert. At least you're pretty sure that's what they are. One of the documents contains a list of left-right instructions, and the rest of the documents seem to describe some kind of network of labeled nodes. It seems like you're meant to use the left-right instructions to navigate the network. Perhaps if you have the camel follow the same instructions, you can escape the haunted wasteland. After examining the maps for a bit, 2 nodes stick out, A, and Z. Feel like A is where you are now, and you have to follow the left-right instructions until you reach Z. This format defines each node of a network individually. For example, RL, AA equals BBCC. Starting with AA, you'll need to look up the next element based off the next left-right instruction in your input. In this example, start with AA and go right by choosing the right element of AA to CCC. Then L means to choose the left element of CCC to ZZZ. By following the left-right instructions, you reach ZZZ in 2 steps. Of course, you might not find ZZZ right away. If you run out of left-right instructions, repeat the whole sequence of instructions as necessary. Right-left really means right-left, 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 and so on. For example, here's a situation that takes 6 steps. Right, left, left, right, left, left, right, left, left, right. Starting at A, yep, I see that. Starting at AA, follow the left-right instructions. How many steps are required to reach ZZZ? So they give us 2 inputs, which is interesting. I'm inclined to just take both of them. Close all this stuff. Close day 6 and 7. Yeah, day 8 tests. I'm inclined to have like 2 different inputs. since they were so nice and gave us 2 examples. Okay, so 2 and then 6, right? 2 for the first input, 6 for the second input. All right. So we're taking the first line and then taking the characters and just using them to navigate, right? And we want to put it into, I guess, a vector because we're going to like cycle through it. Try to think if there's a way to loop it built into Rust. I can't think of one. Anyway, the second, so we'd skip a line. Actually, I think the way I've written it, it would intrinsically skip that line, but we'll have to see. Then we have to read in the steps, and I guess this just is a map, a simple map, right? Split on equals, get the left and the right. On the right, I guess we're trimming and then chopping off the parentheses and then splitting on the comma. Yeah, it's parsing is a little interesting. So let dirs and map equal lines input. Hold on. Dirs equals, well, lines, mute lines equal lines input, right? And then the directions is lines next, unwrap, hairs, map to C match C. And then we're going to collect this into a vector. Okay, the match is going to be either an R or an L, right? Let's do L first. Let's map L to 0 and R to 1. And everything else is unreachable. Okay, so that gives us a vector of numbers. And then let's let the map equal lines map so with a given line we want to split, so it's key and I guess dirs, right, equals line dot split once on equals, right, unwrap. So that gives us 2 slices. So the directions, let's first dirs trim, and let's strip the prefix and the suffix. And then we split at commas, right? And then map each of those directions. And then we're going to end up collecting that, right? Let me think about this. Collecting into what? I guess a vector. Okay, and then so the direction. I want to make key trim, by the way. So each of the directions is like two possible, well, n possible destinations, right? Actually, it's not directions then, is it? It's steps or something? Destinations? Dests. We'll call it dests. Actually, I guess I just want to do a trim after I do that map. So it's just str trim, right? So we just get a vector of slices. So then um don't we want to just form a tuple with the key and the destinations and then collect that into a map? And we get hash map from a slice to a vector of slices. Right. So with that, I think all we just do is we starting with AAA, we keep following the directions with the map until we get to ZZZ, right? So, oh, popcorn. Thank you. No thanks. Mm. Oh, popcorn. And there's a dog. You can't have any of my popcorn. All right. So I guess we're just doing let mute position equal AAA. And then while position is not equal to ZZZ. Oh, we also have to know which direction, I guess. So let mute step 0. So let's make that a step index. And this is a step equal dir, is it dirs? Yes. Dirs get step index mod dirs.length, right? I guess I don't even need to do a get. I can just index directly. So that gives me a number. And then that number I want to use to index the entry. So we have to get the current map. I guess it's the destinations, right? That's destinations if we get the current position as the key, right? And then unwrap that. So then the position equals the step. No, the destinations index the step. And then we have to also count. So num steps, I guess, because we're returning that. Num steps plus equal 1. Cool. So let's try that out on our test. I think we hit an infinite loop. Yeah, something tells me that didn't work. So let me think about this. So I think what we'll do is we'll DBG all of these. And then we're going to say if num steps is greater than 10, break. Just so we can see what's going on. Hey there, Nightshade Dude, and hey there, A Squared. Wow, you guys came in just at the same time almost, and A Squared, again, you're not first. You're still second. That unused mute on step index seems suspicious. You don't have the context? Yeah, probably. Oh, yeah, you're right. I should have paid attention to that. Um, these are redundant, right? That's probably what it is. I don't want num steps, I want step index. But just in case, let's break if we stop early. What's my U size? Oh, as U64. All right, let's try it out. Yep, that's what it was. And here are the steps we took. Oh, I actually didn't debug the current position. I just debugged the map entries. So it really wasn't that useful anyway. So once again, A squared, you always find my bugs. Actually, the compiler did. You just pointed out that the compiler had told me about it. Let's get our puzzle input. Wow. Is that multiple lines? Or is that one line? I guess we'll find out. Day 8 input, paste. Go to the top. No, it is just one line. So we're probably good, right? All right, let's try it out. So I need to go to my normal shell and run day 8 part 1. 11. Really? It can't be right. That can't be right. Nope, it's not right. I was thinking that can't be right. Why does it think it's 11? Oh, probably because I have a break in there. Okay. Okay, 18,113. That's more like it. I gotta wait 39 seconds. Siri. Siri. 39-second timer.
39 seconds. Counting down.
Greetings, C17R. Yeah, slightly different answers. So when Siri tells me, probably I don't need to. I did this to cancel that timer. Let's wait another like 15 seconds and go again. I guess meanwhile I can look and see what I can clean up here. We don't need that. All right, it's probably good enough now, right? Submit. Yay, we got a star. Part 2. Sandstorm is upon you, and you aren't any closer to escaping the wasteland. You had the camel follow instructions, but you barely left your starting position. It's going to take significantly more steps to escape. What if the map isn't for people? What if the map is for ghosts? Are ghosts even bound by the laws of space-time? Only one way to find out. After examining the maps a bit longer, your attention is drawn to a curious fact. The number of nodes with names ending in A is equal to the number ending in Z. If you were a ghost, you'd probably just start at every node that ends with A and follow all the paths at the same time until they all simultaneously end up at nodes that end with Z. Huh. For example, that here there are two starting nodes, 11A and 22A. Simultaneously navigate away from both nodes you're currently on. Repeat this process until all of the nodes you're currently on N and Z. So in this example, you end up entirely on nodes at N and Z after 6 steps. Interesting. Okay, well, we got a different set of inputs for part 2. So I guess I'm putting it here. And we're copying this line here, calling it input 3. Copying this line here and pasting it. And 6 is part 2, input 3. Okay, then. Had to listen to Sandstorm on repeat while doing this level. Is that a? See, I'm not very good at. I'm not very knowledgeable about different music, so that's probably a song that I should know and I don't. Run the test. Does it work? Of course it works. No, it won't. It'll say 6 doesn't match 0. So what's different about this? The directions are the same, right? Only the starting position is we have to find all the ones that start with A. So there are 2 of them. And then kind of walk them all simultaneously until they all get to Z. Gets memed on a lot, but it's still good. See, I've never heard it now. Now I'm gonna have to listen to this song called Sandstorm. I won't be doing it while doing the Sandstorm problem, but that's okay. Uh, because I've already made this, let's do the parsing. Let's make the parsing common. Okay, so function parse. So we get a vector and a hash map. I'm cheating. I'm looking at the info tips. Hash map string, vector string. I guess, can I do a infer? Don't know if I can do this actually. I can. Yeah, see, if I don't do that, it'll probably complain, right? Or does it not even matter because there's only 1 borrow, so it just figures it out. Yeah. It's if we had 2 borrows, I guess we would have a problem. Okay, so that's, I want to just put this in there. Actually, all of this. And return dirs and map. Okay, and then we just say let dirs map equal parse input. Parse input. All right. Underscore is never needed in function signatures. You don't need the take underscore at all. I think there's only 1 input lifetime. Yep. Yeah. Should I try the naive approach? That's where we're going to look at all the keys of the map and grab the ones within an A, right? Pauses equal map dot keys dot filter. We only need a filter, right? Key ends with A. I guess we got to collect that, right? Our favorite data type, vector. So, triple borrow. We get rid of some of these borrows. What if I do a copied? Then we get rid of the extra borrow. Okay. So I think what I'm gonna do is they all have to simultaneously end, right? So I guess what I'm gonna do is I'm gonna say let mute any or all z's equal false. And then when we do a step, we'll set this, we'll start it, we'll be optimistic at first, but then if any is not ending in a z, we'll set it back to false. So we can just do while not all z's. It just seemed like the right thing to do to remove the excess borrows. Um, maybe it's not necessary. I don't know. Okay. So we have to do this for all of them, right? So for pause in pauses, iter mute. And that has to be dereferenced, right? Okay. So it all still works. So then if pause ends with the not, all z's equals false, right? Okay, where's my error? Escapes function. Static. I mean, that'll work, right? Being lazy works this time. Okay. Nope, that worked. So I don't know. Am I naive to think the brute force solution will work here? Maybe I am naive. It's gonna be running for a while, probably, right? Should look at our input and see. There's probably a lot of them that end with A, right? Find something else to do, right? No, it's like try to think of a better solution. So you know what I'm thinking is maybe it's because we're looking for when they all simultaneously hit an end point, right? Shouldn't we instead be like looking to see like how long it takes? Like, say we have like 10 positions. We take the first one. Maybe we walk it to see at what points does it reach a z, and we see if there's a pattern there. And then we do that for the second one too. Maybe there's a pattern to that. And maybe then we can maybe then we'll learn something like we'll extrapolate that, oh, well, it's probably in the billions, but it's extrapolated as the product of some things, right? So yeah, I don't think this is going to ever, I don't think this is ever going to terminate on its own. But I guess I should at least look and see, is it progressing? What's the best way to do that? Like, maybe like print position with a space. and at the end do a print line. Can you do a print line without anything in it? Yeah, you can. Okay, just curious to see what does this show me. Okay, so there are only 6 of them. Interesting. So it should start with okay. We went way too many. How about we'll just end early. And I have to this time. Don't forget to remove this. Although if it's 10 is the answer, I'll know that it's not the right answer. Yeah. So okay, we picked the ones to start with A, right? So now I'm curious to see like if we just maybe we just do the first one only and we see like how long it really does take to get to a Z, and then we keep going and we see if there's a pattern to it. Yeah, there's only 6. That makes me wonder like it's the product of if these are repeating and somehow if they end up to where they started, then we'll know that there's a period to it, right? Aha. That's what we're gonna assume that each of these columns ends up ends up getting back to where it started, and along the way it'll have reached a Z, one that ends in a Z some number of times, maybe once, probably once, right? Now we're looking at like offset cycles, and so we're gonna want to then take the least was it the least common multiple of all 6 of them, offset by a certain number. Let me think about that. If it's offset, yeah, there's some kind of mathematical approach to this, right? So I'm curious. Let's have it print out. Let's say it ends in a Z, right? Let's just have it printed out. Print line. Let's get an N. Intermute enumerate. Okay. Then we're gonna print N step index. Okay. Now let's let it go to 100 and see what it does. Wait, it's never hitting anything with ends in a Z? Huh. Well, let me comment these out to begin with. Let's go to 10,000. Wait. Is it never hitting one with a Z at the end? Or is it just taking a long... Oh, here we go. So we do 5, 4, 3, 1, and then 0. Takes 20,000 steps. So there is a cycle. See that? Yep. There's a cycle there. And then 1 after 18,000. Yeah, roughly 18,000. Okay. Let's also print out the step. I guess I can say pause. LSZ. Yeah, see, it's hitting the same one. One is CHC, CHC, CHC. So I have an hour before the next puzzle unlocks, right? I could probably figure this out. They're all hitting the same one. They're all going in a circle and ending up hitting the same one, right? All 3 of them. Z Z Z. There we go. 4 is X Q Z. Okay, then 5 is KMZ. KMZ. Okay. k. Let me record the number, and then when we get to the next one, we'll take the difference from the previous. So that means that I want to have let mute last term goals hash map new. Okay, and then we'll say what we'll print there is step, well, steps since last term. Actually, if I'm going to do that, I can just put that straight in there and get rid of the comma. Okay, we just need to define what this is. So let that equal last term get n or unwrap or, right? 0. And then we're going to do last term n equals step index. Oh, and we need to take the step index and subtract that, right? Okay, what does it not like about this? It doesn't know what the keys are. What is n? U size. So can't it figure that out? Why does it need to be a 0? Oh, we can't index a hash map, right? Yeah. Okay, so this is insert n step index. Okay, then why does it want to borrow there? Oh, copied. There we go. All right, let's run that. Okay, so then going back up to the top. So 2569. Okay, interesting. So if it's one more, what does that mean? That we started like one after the end, right? So, and on this one, is it also, yeah, so it's always, it's ending up going in a circle and we're starting one after the destination. So if we went back one, if we rolled back one, we would have been at the end. 2, yep, same thing. So the pattern's there, right? So now I think it has to do with, actually, if we're all, if, okay, I know what it is then. If these are probably all prime numbers, and we just need to multiply them and then subtract 1. Because if it's one less step than if they all started at the beginning and we went a whole cycle, right? So we just need to take all of these numbers, add 1 to them all, multiply them, and then subtract 1. If I'm right that these are prime numbers. So I guess what we're going to do then is we're going to repeat until we have that last term in all of the positions. So this isn't while all z's anymore. It's while last term length is less than positions length. And then I don't care about this anymore, right? And then we don't need to do this anymore. So now it should only run once, right? It ran once, right? Now we're going to take all those numbers, add one to them all, product, and then subtract one from the answer. Because I'm just making the leap of faith that these are all prime. So last term reduce, well, map into iter, map n to n minus plus 1. That's the cycle length, right? And then we need to take the product, and then we have to subtract 1, right? Why is it a tuple? Oh, because I want the values. Product. Oh, probably I need to dereference that. Okay, what do we have an iterator of? We have an iterator of u sizes. Can I not take the product of them all? Oh, I guess we want to. Okay, I want to turn them all into U64s. Still can't take the product? Really? Cannot type annotations needed. I don't know what I'm doing wrong here. The product would work. Sup, Pylang? Curious to see if it works. It probably won't work, and then I'll be back to the drawing board. If they're not prime, then it means I need to take their common factors and multiply together their common factors, which is going to be like a pain. Why can't I take the product? Why does it say type annotations needed? Okay, do I just need to say like product U64 or something? Why did I need to do that? Okay, yeah, this is redundant. I don't know why I need to do that, but here we go. Okay, that's a big number. I'm guessing it's wrong, but I could be right instead of wrong. Nope, it's too high. So what? I need to probably just need to take their common factors. It's these plus 1, right? Well, I could just test to see if they're prime. So I'm guessing there's like a prime check. Online prime, enter a number 3. Okay, cool. So I want 13,201. Oh, it's divisible by 43. Okay, so it's not prime. Can I just do the rest by hand? Because I need to take their common factors and then multiply them together, basically. It's a prime factor. Prime factorization. Prime factorization calculator. Here we go. So 13,201. So we get 307 and 43. I guess let's just write these down. 307 and 43, right? Okay, the next one was 16,271. That's 307 and 53. Okay, next one. Third. Let me write it down here first. 18,113, right? 18,113, calculate. See the pattern? It's 307 and 59. 307 and 59. Okay. I'm going to guess I just need to divide my answer by 3 to the 307 to the 6th power. Okay, so the next one is 18727. I just don't feel like doing a prime number factorization tonight. So 307 and 61. I feel like I'm going to get the answer soon because we're seeing the pattern emerge from this. 20,569. 307 and 67. And finally, we got 22411. 307 and 73. Okay, so what is 43 times 53 times 59 times 61 times 67 times 73? And don't we need to multiply by 307 at least once? I think we do. So, eval. Let's try this answer. We got it. I figured it out. So I kind of cheated because there are only 6 numbers, but we needed to take the factors, the prime factors, and then multiply all of the common factors of all those numbers together to get basically at what point do they all line up, right? I remember a little bit about math to know this. Okay, how was my time? So it's 48 minutes. Actually, that's not bad. Under an hour. Least common multiple, yes. So if that's built into Rust, we could actually use that to get the answer. I have some time to kill anyway, right? I got 50 minutes. So let me try to have it actually print out the correct number rather than printing out this number that's too high. So the problem with this one is it has 5 extra 307s in it, right? Because we just multiplied all of these numbers. Oh, you know what I just realized? I never added 1 to it. Right? Aren't we off by 1? Shouldn't it have been blah 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 78 because oh no, subtract 1 from that, right? Because we're already one step into the cycles. Is this off by 1? Are we just like lucky that we weren't off by 1? Yeah, what happens if I apply that to the unit test? Am I off by 1 in those numbers? So that was 6, right? How come I can't run it? Run it, please. There it goes. So I got a 1 and a 2. Prime factors that are 1 and 2. So we're supposed to add one of those 2 and 3, and we get 6. Yeah, wait a minute. Wait a minute. Oh, how's it going? Yeah, I just did day 8, part 1 and 2. Wait a minute. The answer is 6, but we guessed 5 because our... No, it is 6. Okay, so why do we not subtract 1? Let me try to reason that out. So where does the cycle happen? Left, right, and then from 1, 1z, one more to go back to the... Oh, I see. So I see what the problem. I see it is. We never go back to 1, 1a. 1, 1a is like the special starting one that goes into the cycle, which is 1, 1b to 1, 1z, back to 1, 1b, back to 1, 1z, right? Okay. So the subtract 1 is wrong. So remove that part, right? But then rather than taking the product, we want the least common multiple. So there probably is no LCM, right? But that won't stop me from asking find. Is there a function in function in Rust to compute the least common multiple of a list of numbers? Yes, there's a way to compute the least common multiple of numbers. You can use the LCM function from the num crate to compute the LCM of 2 numbers, and then use the reduce function from the iterator to apply the LCM to all the numbers in the list. Okay, so the num is at 0.3. So I'm using AI for good right now. So I need to pull that into my cargo toml. Num. The AI thought we were at 0.3. Is it right? No, we're at 0.4 now. Close enough. Okay, and then this says I can do a reduce. So that's what we're going to do. We're going to reduce n LCM. Yes. So this is wait, that you can't reduce LCM. Well, let's map this first, right? And then we'll reduce. I don't think it's going to let me do that. Yeah, see, like, oh, actually, almost. Cannot find value LCM and create num. So, oh, it's num integer LCM. Okay, so there is. So, yay. Thank you, AI. Let's see if my unit test works. How come this doesn't always work, the button here? There it goes. Yeah, it worked. So, running on the real one. Yeah, AI is okay. It sometimes hallucinates the answer, but that's okay. You know, it gets close enough that I can kind of figure it out. So that's the number I had, right? 1, 2, 3, 1, 5, 7, 8, 8, 1, 5, 9, 9, 7, 7. There we go. So it's working. Now, do I keep these? I kind of like that it printed those out, but these are... Maybe we don't need them anymore. If I ever want to see them again, I'll just look back at the VOD, right? Which reminds me, I need to start uploading the VODs to YouTube because actually let me check. Did I already lose some of them? How far back do the VODs go? Ooh. I need to export them right now. Expiring in 0 days is not good. Okay, so export. Let me do that off screen. Export. So what do we want to say? Advent of code 2023. Um, this is me solving Advent of code 2023 days 1 and 2 in Rust, using the Rust programming language. Programming language. Okay, and the public visibility, right? Export. So I'm just exporting to YouTube really quick before I forget again. So this is day 3. I'm just going through my own VODs. Don't mind me. Public visibility. Export to YouTubies. Export. And then we did day 4. Export. And then I did day 5. Only a couple more clicks and then I'll get back to you guys. So export. We did day 5 after we did day 4, which makes sense. And then we did day 6 and 7 together. Export. Days 6 and 7. Okay, so that means I lost a VOD because right before AoC started, I did do an extra day of Data Disintegrator. So, oops. Oh well. Bummer. I lost a VOD into the ether. I recorded it locally so I can get it back in. Hey there, Stripe Monkey. All right, so that's our solution. We had to add one because it takes one step to get into the cycle, and then we're at the beginning of the cycle, right? So then we have to go through the cycle, the least common multiple of all of the cycle lengths, and that's how many steps it takes. Yeah, here's that print line we don't need anymore, right? And I didn't need this. Cool. Looks like I'm failing. Oh, because we didn't do day 9 yet. There's a warning somewhere. It's on day 9. That's why. Yeah, we haven't done day 9 yet. Day 9 we can't do yet. That doesn't start for another 40 minutes. You're back. Welcome back. Okay, so let's see how fast people did day 8. 4 minutes? That's not bad. It's pretty dang impressive, if you ask me. 38 seconds? What? How could someone do this in 38 seconds? Part 1. How did someone do all of this in 38 seconds? I'm guessing they must have had a parser already. They must have if you started with a parser, maybe you could do this in 38 seconds, right? Because you're like, "Oh, I have the parser for that exact thing. Now all I need to do is walk through it until I get from one to another, and then that number of steps is the answer." Code golfers are crazy. Wow. I'd have to go back in the VOD to see how long it took me, but I got the whole thing in 45 minutes, right? Too late. Too bad that we started so late. So because that means like my personal times are going to be 22 hours. Actually, from this minus this, I can kind of see how long it took me. So that's 28 minutes. So 28 from 45 is roughly 17. So I did it in 17 minutes, part 1. Well, actually, I can see that um, it's been an hour, and that means I started at 7:21. Yeah, so it's about 19 minutes, 18, 19 minutes. So if someone who's done this and they started at midnight and it got around 18 or 19 minutes can tell me what their rank was, then I can kind of guesstimate what my rank should have been if I started on time. Okay, what do I do for 38 minutes? I don't know. Should maybe consider cleaning this up. I should look and see how this worked because I didn't think map could be given two things, but I guess it can, right? The only way for that would have that to work is if reduce. Oh no, reduce does take two things. Okay, so that's perfect. It fits there exactly. So LCM works there. Nice. Like the Linux pass in my on-screen chat. Yeah, that when whenever someone compliments that, I got to shout out the author who is CM Griffing. He made that. It's called Stream Parrot. All right. Did I use that N? I did use that N, and I used the position also. We could we could improve this a little bit, right? This last term we could skip it. We could skip. We could do an early skip here if last term already has something in it. We could say if last term dot contains key n. Continue. Don't know if that really matters, but it shouldn't change the result, right? I guess it would be even better is if we just dropped it completely out of the positions. Wouldn't that make more sense? Once we find how long a cycle is, we don't need to keep going. So instead of doing these length comparisons, we can just say, well, the positions has something in it. Right? So then this becomes while not positions is empty. Then instead of continuing, if we get to here, we actually want to remove it out of here, but we've iterated it, so also we have an n here, but that's okay. We don't need to have an n. We could just push here. So this could actually just be a vector. And this is into iter. And this is push step index. And this is a into iter. Position, yes. So what we want to do is else. Don't I just want to turn this back into poses equal into iter enumerate filter map position? That's an n and a position. Actually, I don't need the n. I don't need the enumerate. And this is a none. Also, this is a position. No, dests. Well, we can just say let position equal that, and this is a sum position. Why does it not like this? Oh, I need to collect it at the end. There we go. That should still work, right? Only this doesn't need to be enumerated anymore. Yep. Cool. So this should really just be positions. Positions is map. Yeah, find all the starting positions. Then last term is really cycle length. So we're collecting into the cycle lengths. Every when we hit the end, we take the number of actually, and then I can add one to hit here, can't I? Can I just like directly turn this into an as U64, and then I don't even need this map here? Yeah, look at that, making it better. So given a bunch of positions where every step we're basically filtering out all the ones where we hit the end, and if we didn't filter it out, we're advancing it a step. Um, Actually, this step index, if I can make this whole thing an iterator, then we could use enumerate to get that, right? I don't know. Good morning, Code Monk. How did you do on day 8? I know you're beating me on all the leaderboards. Not that one, but you're on the Primogen leaderboard, right? Look at that, Code Monk. Actually, Code Monk, and now 3 other people have caught up, and they're ahead of me. I'm now dropped to 5th place. Actually, do you guys happen to know if Primogen has another leaderboard? Because the account he used for last year has no points, but I know he's been doing admin of code, hasn't he? How'd you do negative access for cyclic arrays? I did a modulo. If that's what you're asking, like we're cycling by doing a modulo. Didn't bother with cyclic arrays. You use iter cycle, which makes the iterator repeat forever. Hmm. He had an older one, but I think I dropped out of it. Yeah, I'm only in one Primogen leaderboard. But anyway, Code, you can see CodeMonk's superior to me in ability to speedrun admin of code. Either that or it's just because I'm kind of crippled by the fact that I can't start a lot of these on time. So day 8, 6, and 4, and 1, I couldn't start on time. Blame World of Warcraft for that. Yeah, how else can I clean this up? So you start on time every day? Okay. I don't know about that, Code Monk. I thought yesterday you got it first before I did. Struggling because you're doing this in Rust, which is never programmed before. Well, that's part of the fun, right? And as Eric likes to say, the thing he likes about making admin of code is watching people learn things. Premise 2 private leaderboards. Yeah, I know it, but I thought he deleted the first one. So am I on the wrong one? Did I delete the wrong one? I must be on the one that he this is the account he's not using anymore. Let's see how am I doing on this one, which is super competitive. Have I dropped down? Yeah, okay, now I'm on 33rd place instead of 25th place. A lot of competitive people on this one. Oh, thank you, Nightshade dude. Yeah, love to see how he's doing on this. You're at Go in your work life? Lucky. I'm stuck with C++ most of the time. That's why I do Rust on stream. I need to not forget my skills, and I would never have a chance to work on Rust if it weren't for my own projects on Twitch. That's okay, Nightshade dude. Don't worry about it. That means he's probably not doing day 9 tonight either, right? Okay, positions into iterator. See, I don't like the fact that I'm taking it and putting it into an iterator and then having to recollect it again. It would be nice if I could like iterate and then I guess we could do well, what I was doing before was I would iterate it in place, right? But here I wanted to actually filter it so that it actually gets smaller and smaller, which is a speed advantage, right? Once you found the end of one of the paths, you don't need to keep iterating it because all we wanted from it was the cycle length. I'm trying to think, is there a more efficient solution than having a vector that we turn into an iterator and then replace with a new vector at the end? We don't know the length until we filtered, but we know that we can cap the maximum length. So, like, I could iterate a vector in place and just have a number of positions that and maybe we do a take on that. So maybe that's better. So what if we do it this way? So we do a let mute num positions equal positions dot length, and then basically instead of not empty, we do while num positions is greater than 0, and then we're going to hold on. I can't iterate it mutably, can I? No, I don't want to iterate positions at all. Actually, I want to iterate from um, for the linter is going to hate me for this, but for n in 0 to num positions, right? We want to do let me think about this. Let pause. Yeah, we're going away from iterators here, but that's okay. Positions n. Actually, then what we're doing is we're reusing num positions. So let num positions last. And this seems like a more hacky way of doing it, though. So instead of doing this none thing, we would say positions num positions equals position, and then add 1 to number of positions, right? And then we don't do a collect here, right? Let's see if that should give me the same answer. Yeah, so it gives me the same answer still. Only it's more traditional, and there are not as many iterators. But it didn't give me a warning, so maybe it is better. Used to keep track of the invite codes for all the lists you're on, but you think you've lost it? I just should never have left the other one I was on. Is there a way to get the invite code for leaderboards you're on? I don't know. I think you'd have to go to the person who's managing it and ask them for the code. It doesn't look like there's a way for me to get the code that I use to enter that leaderboard. Because otherwise, I guess it might accidentally get leaked. I don't know. I mean, I'm leaking my own private one here. See if anyone's like actually yeah. No one has gotten on to it yet, but probably just cuz no one cares. Okay. So this is maybe a little bit better cuz we're not allocating memory over and over again. In fact, I don't need to do a vector new here, do I? I know what the length is going to be. Can I, if I just remember, yeah, what if I, eh, it's simpler to do a push because then I don't have to do the funky math that I would need to know what to push it into because it's going to be like positions length minus num positions when you get to here, right? To index cycle lengths if cycle length was a fixed array. But if it's not a fixed array, the push is easiest, right? Yeah. Um, or actually, you know what? I could just use I could just use what is it? I guess I can't. No, I could I hmm. Let me think about it. Yeah, two cycle lengths might be computed in the same outer loop. So yeah, we would have to have another counter of the number of cycle lengths. So yeah, anyway, this is probably best, right? You made a bunch of assumptions that just turned out to work for the input, but it could have been much worse. So like on mine, I did the brute force approach, and then it didn't. It was going to take an intractable amount of time. So then I had a theory that we were hitting cycles because like I'm like, well, how else are we going to solve it unless there's some trick like they're cyclical? And then we saw that there was a cycle, and then I noticed that the cycle was always one more. The length of the cycle is always one more than the number of steps it took to get to the end the first time. So I'm like, oh, we're jumping in at the very first step of the cycle. So then all we need to do is get the cycle lengths, and then at first I'm like, let's just because I don't want to mess with prime numbers. Let me just hope that they're all prime number lengths. So I just need to take their product. That was wrong. It was too high. So I'm like, okay, they're not prime numbers. And then um, before pulling in this least common multiple thing, I went and I'm like, let me see what the factors are, and they were all 307 times something else, something different. I'm like, okay, fine. They just Eric threw in that 307 there for me, just so that to make it harder. So I had to take out the 307s from all but one of them, right, to get the least common multiple. Then we got it. So if it weren't for like the analyzing the cycle lengths, I wouldn't have been able to. I wouldn't have known to guess that they were all entering the cycle together. Actually, the problem will be a lot harder if you entered the cycle at some offset, and that's what I was initially worried about. But when I saw that they were all entering it at the beginning of each cycle, I'm like, oh, okay, then we just need to go exactly one least common multiple cycle. Okay, 20 minutes. You know, I guess it's not too bad to just keep looking at this and we can keep chatting until we get to the midnight Eastern time and then day 9 unlocks. What else can I do with this? Yeah, this is that assumption that we start at the beginning of a cycle, right? That the cycle length is the number of steps it took to get to the end plus one because of the initial step to enter the cycle from the starting point, which we never come back to. Yeah, so like this whole thing right here is something I couldn't tell from the instructions. We just had to guess. I mean, maybe you could guess it from the fact on day 8, part 2 here, that you can kind of see that, oh, we go from A to B, B to Z, Z back to B, and now you're locked in a cycle. And the same thing with 2. You took from A to B, B to C, C to Z, Z back to B again. Oh, look, there's another cycle, right? And in both cases, the cycle doesn't include the starting point. So to enter the cycle, you need to take one initial step, and then you're at the beginning of a cycle, and then 2 cycles of different lengths to get to the end of both. You take the least common multiple, right? That's like a little math trick. So we could have like inferred from the example that, oh, our input probably follows the same principle. In fact, I guess we could have also looked at our input directly, right? We probably would have seen something like that. We'd have to look for the one that has an A equal. Yeah, so if we decide, oh, A goes to B, oh, look, that A, oh, that guy goes to a Q. Okay, they didn't make it easy. Okay, so it's hard to see from the input, right? Yeah, okay, so I guess you would have had to make a leap of faith that your input follows the example, and you could use that trick. I don't know. Yeah, I would say that this problem would have been a lot harder to do on the first try. You didn't check for any offset at all. You just took the length it took to reach C and didn't check anything else and took the LC. So you also took like a leap of faith, right? Because what if there was an offset? What if the first step dropped you into the middle of the cycle somewhere, right? Now you're kind of screwed because you have to count for that phase difference. So actually, I don't even know how you'd do that. Is there a predictable way to, based off of the cycle length and the initial phase, to like get it back into phase? I don't even know. Well, it would be the first cycle is reduced. Yeah, I don't know how you do that. There's similar problems you think from your last year or 2 years ago. Yeah, I get scared by these problems that involve math because my math isn't so great. I only remember up to trigonometry. So, and my algebra is also kind of weak. So, like, I don't remember like I don't remember barely anything else other than what I use for graphics, and that's mostly trigonometry and linear algebra. Anything else I can do here? I don't like that I had to have this last and then this, and then we have to count. Actually, do I need this? We don't use num positions, do we? Oh, no, num positions, that's the only way we know how many positions we filled. And that was the compromise I made for like not reallocating memory every loop. Is we basically pre-allocate the memory here and then we reuse it there. But we have to know um how many we're actually using because it goes down, right? It goes down until it gets to 0 and we're out of the loop. You know what, I could cheat and actually reuse the positions vector for the cycle lengths. Because what we can do is we could use the end, we could count backwards from num positions and put it in back into positions. Would that would probably make this totally unreadable, but I could do it. Day 17 from 2022 is pretty similar to the harder version of this. Ah, well then. It's probably a day I would have skipped. Okay, so yeah, I could do one less memory allocation if instead of cycle lengths, I put this into positions and then this becomes positions. Oh wait, no, I can't. Positions is a vector of slices, not a vector of. Okay, yeah, never mind. It's a different type. We need a vector of integers rather than a vector of slices. I think I'm not gonna do much more on that. Removing the parentheses by doing strip unwrap seems kind of brute force to me. I wonder if there's another function in Rust that'll do a trim but with parentheses. Like what we really want to do is do a trim of white space and then do a trim of parentheses. Right? Which is that. I guess we could make our own. That doesn't exist. We can make our own, but do I care? I don't know. Are you in leaderboard 766471 or 1080495? I won't know unless I join them. Is that bad to just join them? Join 766471. That doesn't even look like a valid join code. It looks like the leaderboard numbers are two numbers. First one and then a hexadecimal. Oh, click on the Primogen in the URL. 1080495. The second one. Can I even view the other one? I can view it. No, I can't. It dumped me back out. I can't just type a number in here. Oh, you gave me an invite code. Thank you. -9EA1D79B. Join. Woot! I'm into the Primogens. Thank you, Nightshade Dude. Okay, so I thought he said having a code was against his religion. But he's already on day 7. Nice. Wait, I lost. Okay, he's in 65th place. Where am I then? I'm pretty far down. This is a pretty competitive board also. Oh, look, I got exactly 2,000 points. Should I just stop now while I'm ahead? I'm at 2,000. That's a really nice place. All zeros except for the first digit. I love it. Okay. Not even joking. Do I know anyone else on this list other than myself and Primogen? And that's saying a lot that I even know myself. I know. Where's Nightshade, dude? Don't even see where you are in this. Oh, I did this before, and how do I get out of it again? I entered full screen. Exit full screen. Okay. There you are, 85th place. You only done the first 3 days? Come on, man. Gotta catch up. Cool. All right. We got 9 minutes to go. All right. I should probably make sure that we are ready to start. So let's close some irrelevant things. Okay. Let's assume we're using hash map because generally 50-50 chance we're going to use it, right? Probably not going to use that one. Erlang is hard and very. Oh, so you're using Erlang to solve things? I was thinking maybe next year I try to solve it in a language that I invent just for solving Advent of Code challenges. Because other people do that. And I know how to make a compiler. Wouldn't that be fun? Just spend the next year making a compiler for a language that's like focused on solving Advent of Code problems. That should say day 9, shouldn't it? AoC Lang, yeah. That's open source one, right? Nice parsing syntax would be a huge help. I got to keep the timer in mind. I can't like spend more than 8 minutes looking this up, but there's probably an AoC Lang, right? Maybe with the dash or another obscure coding language. Oh, it's an interpreted language written in Rust for fun and learning. Hey, look. Maybe they're doing it now. Because that's literally now, right? Yeah, this is what I was thinking. Something simple that like doesn't have a whole lot of syntax, but lets you make variables, does math. Yeah. Yeah, just basic stuff. Okay, this is a little bit too bare bones for me. Because I would just do if expression and like if zero not zero otherwise, like I would just make that one kind of expression. You did AOC in Python? Actually, you know what I'm going to do? I'm going to go get a cough drop. I'll be right back. I was the chair stream. This is actually not too much different than the language I made for Data Disintegrator, right? Oh, except for it's got objects. They were getting a little bit complicated. Oh, they hit all their to-dos. Oh, they don't have break or standard library. Oh no! I'd be curious to know if this person is actually doing AoC2023 with their invented language right now. Actually, let's see. Uh, if I go, do they have AoC2023? Oh, they do. Did they solve it in their own language? They did. Hey, let's look and see how he solved it with his own language. That's cool. Yep, he figured it out too that there's cycles. Nice. You went from rank 5900 to 1700. Yeah, it's part two seemed to be like one of those where if you figured out that you were looking for least common multiple of cycle lengths, then you could do it pretty quick. Otherwise, you'd be kind of stumped, right? Right, Betseg? That's pretty cool. I don't know how to solve this. So that's cool. He did it in 67 lines, whereas it took me a lot longer than that, right? Oh, not that much longer. 76 lines. You just left your PC running for a week to generate the answer for like how many iterations? Million, billion, only 12 trillion. Actually, that might, you could maybe brute force that one. I wonder how long it would take to brute force 12 trillion iterations. Top three? Who's top three? Which one's this? Is this the Primogens? Oh, Primogen. How did I get top three? I thought I was further down in the list. Oh, this is 2020. Yeah, I'm getting older. 3 years later, and look how far further down I am, right? All right, we're coming up close, right? I can't dawdle. We have 2 minutes. Okay, good luck to everyone else who's trying to do this, especially if you're trying to hit the leaderboard. I have no hope of hitting the leaderboard. I'm just having fun. I wonder if we're going to get to the next island now. Yeah, it's over. Yeah, I should just hang up my hat. Hang up my elf hat and retire. What's a sponsor? Oh, that's an actual organization. Huh. Gets a lot of sponsors. That's pretty cool. Think we'll be making a way to get to the new island. Yeah, it looks like each island has like 2 or 3 spots on it, and we're about to get to the third spot on this desert island, right? So we were on a cloud island, and then we were on an island, and now we're on a desert island. Um, so we're gonna find a way off of the desert island, I guess. More ghosts. Maybe the next island will be the ghost island. This is reminding me a lot about Super Mario Brothers. We're on World 3 right now, apparently. All right, 1 minute to go. See ya, Betsy. Good luck. Nightshade Dude, are you going to do it? Are you going to do day 9? You don't have to catch up and do days 4 through 8. You could start on day 9 and come back to day 4 later. Yeah, you don't have to start on day 4. Did I have any? I did have 2 mutables. I had 3 of mutables. 4 mutables. Wow, I had a lot of mutables. Betseg beat me on that. Okay, see, I lose on the leaderboard just because I actually read the text. It seems like the people who get on the leaderboard don't even have enough time to read the thing. 4 looks like 9 is close enough for you. Yeah, there you go. It's still single digit, right? Still in the single digit days. Okay, here we go. You ride the camel through the sandstorm and stop where the ghost's map told you to stop. The sandstorm subsequently subsides. It's a lot of S's, by the way. Somehow seeing you standing on an oasis. Okay, this is the S day. The camel goes to get some water and you stretch your neck. As you look up, you discover what must be yet another giant floating island. Aha, this one made of metal. Okay, that must be where the parts to fix the sand machines come from. There's even a hang glider partially buried in the sand here. Once the sun rises and heats up the sand, you might be able to use the glider and the hot air to get all the way up to the metal island. While you wait for the sun to rise, you admire the oasis hidden here in the middle of Desert Island. It must have a delicate ecosystem. You might as well take some ecological readings while you wait. Maybe you can report any environmental instabilities you find to someone so the oasis can be around for the next storm-worn traveler. You pull out your handy oasis and sand instability sensor. Oasis, yes, and analyze your surroundings. The oasis produces a report of many values and how they are changing over time. Each line in the report contains the history of a single value. So that's a single value, there's another single value, and there's another one. They're all increasing. To best protect the oasis, your environmental report should include a prediction of the next value in each history. You know what I think it's going to be? Part 1 is going to be increasing linearly, and part 2 is going to be either decreasing like a parabola, or it's gonna be like, yeah, it's gonna throw us off, right? Start by making a new sequence from this difference at each step of your history. If that sequence is not all zeros, repeat this process using the sequence you just generated as the input sequence. Ugh. Difference at each step. Let's see how they do that. Because the value is increased by 3 each step, the first sequence of differences that will generate is 3, 3. So there's, yeah, it's in between. Or you can just say you're reducing, and you get one fewer step each time. Yeah, one fewer value. Since the values aren't all 0, repeat the process. Difference by 0 steps, so it's 0. This means that you have enough information to extrapolate the history. Visually, these sequences could be arranged like this. To extrapolate, start by adding a new 0 at the end of your list of zeros. And then you can start by filling in placeholders from the bottom up. A needs to be the result of increasing by 3. Because otherwise it would be, yeah, A would be a 3, right? That's the only thing it can be. And then from there it's 15 plus 3, which is 18. Yes. Finding all 0 differences of the second history as an additional sequence. Yeah, okay, so this is a line. This is a exponential, a square, right? And this is a weird one. Is that a cube? Huh. So anyway, what are we doing? Oh, so we're getting the extrapolated value of each line and adding them together? Add them together. Okay, so 114. All right. This one looks fun. I'm kind of scared about the math though. All right. Here is our original input. Okay, so each one's independently done and then added together. So let's at least do that one. So it's lines, input, and then map through something. So extrapolate, right? And then sum them. So extrapolate is going to take, so extrapolate takes a line and returns us a number, right? So first thing we want to do is, I guess it's line split ASCII white space and then map through string parse. Let's do a cheat here. Flat map that to make that an option, and so we don't actually have to unwrap that anymore, right? So we parse it, and then how are we gonna do this thing? I guess we're gonna collect it and then do a process where we iterate them, find their differences, and we do that until we get to 0. Actually, do I need to follow it? This might be misleading us. Do we have to do it in with their approach? Maybe, maybe. So really, every time we iterate, we need to keep the last value. We need to keep the last value of the current line and then the new line, right? So when we iterate these, we generate a bunch of 3s and we keep the 15. Then with the 3s, we'd iterate those and keep the last 3 and we get zeros. And then we're really just adding all the way back out, right? Okay, then what it is every line produces two things. The next line, every number sequence produces two things: the next number sequence and its own last number, and then those we add up at the end, right? Yeah, it's the sum of all these last numbers. It's 0 plus 3 plus 15 is 18, right? 0 plus 1 plus 6 plus 1. Yeah, so it's just the last number of every sequence added together. So can I just use recursion here, or is that a bad idea? I think I'll just use a loop. Mute nums equal that. Collect vec. So we get, why does it result? Oh, shoot, I needed to flat map this. Then yeah, it doesn't know what type we want, but it will soon. Actually, I guess I can just say vec. Well, another way I can do it is put it in here. U64. There we go. So then let's just collect together manually the well, I don't need to collect them. I just need to add them, right? So the sum is 0, and then well, that last number is not. No, they have to be all zeros for us to stop. If there's a 0 intermediate, we don't stop, do we? So we have to we'll just do a loop. So we have to know at the end. This is going to end up returning the sum. Moved on to Prodigy. I don't know what you guys are talking about. Darude and Prodigy. Okay, so the outer loop is just repeating until we get all zeros. So we have to have some kind of let all 0 equal true, and then if we have some kind of loop, well, actually here I can enumerate the numbers. Let or nums equal nums into iter. Um, Let me think about this. It has to okay, we can't iterate them, can we? No, I can't. No, wouldn't I just take the Windows 2, all contiguous windows of length size, they overlap. Yeah. Okay, so it's 2 um map, right? And don't we get like two numbers, A and B? This I'm not too sure about. Is it a tuple or what do we get? Let's see if I do an X, what do I get? Oh, we get a slice. Okay, so we can put A and B, right? Then we get two numbers, right? So then it's B minus A, and then I have to collect them. But I need to remember the last number. Actually, you know what I can do is I can put that last number, I can just add it to the sum right away. So sum plus equal to num's last unwrap. What happens if we get down to no numbers at the end? It didn't tell us what would happen. I guess we'll panic. So, yeah, in here, let x equal that x, if x equals 0, is if x is not equal to 0. You know, I also realized that it might go negative, so let's allow signed numbers. All 0 equals false. Okay, if all 0, break. And sum, let's assume that we can just turn it back to signed. They might all be signed anyway. Okay, maybe we'll panic if we get a negative number in there, right? So we'll just assume that it'll never goes negative. What's the error here? Oh, um, I guess I did the flat map internally, so I didn't actually need that to be an option at all. So I don't need to make a flat map of that. It's still an error. Refutable pattern in function argument. Oh, okay. Well, then it's just gonna be an x. Well, nums. Let. Well, I'll just say nums 1 minus nums 0 then. Okay. We pass. Oh, we don't have input. It would be useful if I got my own puzzle input, wouldn't it? Oh, there are negative numbers in there. Huh? I see them. I'm gonna have to before I run this get it to handle negative numbers. Okay. So these might be negative. Make sure it still works with potentially negative numbers. All right. Okay, we got an answer. Let's see if it's right. Yes. On to part 2. Of course, it would be nice to have even more history included in your report. Surely it's safe to just extrapolate backwards as well, right? For each history, repeat the process of finding differences until the sequence of differences is entirely 0. Then, rather than adding a 0 to the end and filling in the next values, you should instead add a 0 at the beginning and then fill in new first values for each previous sequence. Okay. So we get a 5. That's fun. I don't know, how hard would this be? I kind of like this challenge. Not so hard, but yet interesting. So, don't I just reverse it? Don't I just reverse it and then reverse the subtractions? So wouldn't it just be reverse? Oh, I can't do this. It'll mess up part 1. So let's have an extrapolate reverse. Okay. Extrapolate reverse. Okay, so let's just do a reverse here. Okay, and then with it reversed, I need to actually reverse this, right? Because if it's going to do these two, it's going to need to take, if this is index 0 now, and that's index 1, it's going to take 0 minus index 1 to get that number, right? And at the end, it's going to, okay, at the end, we subtract. So we start at 0, we subtract to 2, so then we subtract. Oh, it's okay. This isn't the okay. The sum starts at 0, but we always take the new value and subtract the current sum. 0 subtract 2, 3 subtract negative 2, 10 subtract 5. Okay, so the way we accumulate is different. So it's not sum plus equals. It's the last number minus the sum. So it's not really sum anymore. Let's just call it the accumulator. So it's the last number, which is like here, or here, subtract a previous. Yeah. Okay, let's see if I got it. No, I failed. I got an insanely huge number. Oops. All right. So reversing it isn't quite right. Can we like dbg this and just see it in the unit test? Yeah, so 15, 12. Oh wait, they took it a third example? Oh shoot. Wait. The sum of the extrapolated values. Okay, so I need to look at the third. So 15. There it is. 45, 30, 21, 16, 10, 15, 9, 3, 0, all 2, 2. We should print out what we're getting. I think then the bug must be in this one. So what if I do dbg run test? So we get 3. I should look at that third example again. So we're comparing apples to apples. Okay, -7. That's wrong. um. Oh, because I didn't. Am I printing them in the wrong order? Hold on. The last minus the previous accumulation value. Oh, I closed it. Run it again. Where's my run test? Sometimes this button goes away and it doesn't work. The button doesn't work. Why are you not working? Do I need to hit save? Ah, there we go. Don't know why it does that. Oh, I am doing the math wrong. Okay, I think I see what the problem is. So that would be the correct math if I was doing it from the bottom up, but I'm doing it from the top down. So from the top down, what do I want to do? I don't think I can. So this one I could do from the top down because it was always just take that one and we're gonna um we're basically adding this right hand side. But instead, what are we doing? For when we're going this way, we're not adding these numbers, right? We're subtracting from the bottom up. 0 minus 2. No, we're not even doing that. Are we subtracting down from the left? 10 minus 3 minus 2? Is that right? So it's the difference? Okay. Yeah, see, I'm not very good with math. So maybe it is subtract. I don't think I need to debug anymore. Maybe it's just subtraction. No, we have add with overflow. Why do I have an add with overflow there? Oh wait. That can't be right. Okay, so I can't reason out how to do it from the top down. So if we do to do it from the bottom up, then I need to what I need to do is actually push something into I need to make accumulation a new vector. And every time we go into this, we're going to take that last number and push it into the end. So accum push the last number in. Okay. So we'll end up with a 0 at the end, right? Which is what we want, because we want to take that 0 um, and subtract. Oh, I see. We're going to take the previous, subtract the current. Yes, so it's accum into iter, reverse it, reduce, um, A and B. It's going to be B minus A, I think. Unwrap. Maybe not. Um, copied. Getting there. Okay. As U64. Okay. um. Wait. What did I mess up there? Is it's borrowed? Oh. This has to do copied. There we go. Accumulation is a vector of numbers. I don't need to copy them anymore, yeah, because they shouldn't have been references. Okay, and then we're not using a hash map. Hey, I thought we would be using a hash map. Turns out we're not. Okay, we're still off. We still have add with overflow on one for wait, what? Add with other overflow where? It's not telling me where. It just says it's add with overflow somewhere. We need to run it with that to see where. I'm guessing it is in here. So what if I just do a 0? Yeah. So we have add with overflow here somewhere. I want to see them. 10302. 10302. Okay. So we do need to reverse them. It would be 20310. Oh, I need to put a 0 on the end. Okay, then I need to do a fold, don't I? Not a reduce. And there's no unwrap. Still an add with overflow. Add with overflow. Add with overflow. Can I do a DBG here? Yeah, let's see that. 0, 2. So that's 2. 2 minus 0 is 2. 2, 0, negative 2. And then negative 2, 3, 5, right? Negative 3, 5, and then 10. Why is it panicking on an add? Why is it? I think it's overflowing. Okay, so let me do a DBG there. Oh, I can't do that. Ah, shoot. Can I do map DBDX? See those numbers? Five, 0, and a huge number. Why are we getting a huge number for that first one? 0, 3, 0. Okay. So it would be 0, 3 minus 0, right? Is 2. And then 0, okay, yeah. So it should be 0. 3 minus 0 is another 3, and then 0 minus, oh, it's negative 3. Shoot. That's the problem. They can't be U64. It has to be I64. This removes that. This has to be as U64 at the end. Can't do a sum there? Why not? Sum as I64s, please. Okay. Is that it? Still get a 2 instead of a 5. Oh, no, 2. The test was just had the wrong number in it. That is a 2. So that should pass. Okay, So then let's remove the DVGs. Okay. So I wonder if I still needed to do this extra step if I could have done it in there. Okay. Part 2. We get 1,005. That doesn't feel right, but let's see. Yep, I got it. I did really one on part really well on part 1. So that the bug on part 2 slipped me up on the time, and I lost some rank. 32 minutes. Yep, and 17 seconds. Could have part 1 for 15 minutes, just like me, and it worked without testing. Nice. Okay, I will allow the bad word just once, Betsy. Remember, I'm a dad, and I always have to tell my kids, don't you use those bad words. Yeah, so what screwed me up on that part 2 and that lost some time was that these intermediate numbers can be negative. And so it was underflowing, and then the sum was overflowing. So, yeah, we have to do a little bit of sign trickery. Or we could have just made everything signed and don't use unsigned at all. So I'm curious, can I like get away with, can I do what I did before? Can I let accumulator equals 0 and then like my original thing was to do accumulator equals unwrap minus accumulator. Does that actually work or no? What? What? Oh, I need to say accumulator at the end. Yeah, will this actually work? No, it doesn't give me the right answer. It gives me some answer that doesn't make sense. Okay, well that answers that. I do need to reverse the final list, basically. Reverse the computation of the list. Do the math from the bottom up instead of the top down. Cool. Trying to think, can I like get rid of this, or can I reduce this like, because I want to do two things at once. I want to do the collect of all the x's, but I also want to have the side effect of knowing if they're all 0 without having to enumerate them again. I guess I could collect two things and then split it. I can't think of any. I don't. I can't think of how to make it nice. Simulated, I think, one of the first computers in history, Babbage's difference engine. Is that what this is inspired by? Like this ladder approach? I know that Eric likes to make these puzzles based off of like things in the real world, and it's not always obvious. And that's because he likes people learning. So it could be that one set of people solving this might do internet searches and end up finding something like Babbage difference engine and would be like, "Oh, hey, that's what we're doing." And they would learn something, right? Anyway, that's cool. How are we doing on the private leaderboards? Actually, hold on. First, I want to see how do people do overall tonight. Wow, a minute and 48 for both stars. A minute and 16. Huh. So if you got the first one, you should get the second one really fast, right? So how fast did Mikhail get part 2? I don't even see him on the list. Wait, what? Oh, Mikhail. Wait, Mikhail got the first one, but not the second one? What happened, Mikhail? How did you only do part? You beat everyone on part 1, but you didn't do part 2? Okay, how about Cody? Okay, Cody, 157 from one, so 36 seconds later. To go from part 1 to part 2, 36 seconds. That's pretty dang impressive. Cat 5 minutes, 32 seconds. Yes. Well, 36 seconds, but yeah. You said, yeah, 36. Yeah, right. Yeah, that's pretty impressive. I can never compete with that. I don't know how they do it. I can only guess. Did bad with part 2? Yeah, well, me too. Join the club, Devil Squirrel. I screwed up and took like way too long in part 2. ChatGPT in action. You think they're using ChatGPT? I mean, it's possible. Yeah, I can tell you how I screwed up. I recognize that you just reverse everything and you do the internal math, but I didn't realize when we're folding these that the answer could be negative. So I had a U64 there, and it was overflowing when it got to my final sum. So it took me about 10 minutes to realize, oh, hey, this could be negative. So I need to make that signed and then do the signed sum and then turn it back to unsigned. 819, that's pretty good. You're faster than me. I was 1522. Anyway, there are probably still people solving this, right? And why chatter about stuff in the past when we can see the future? Let's watch someone else who's working on this. I got to go to the category, I think, right? Well, Epsilon 1 is doing it. And let's see. Is also bad cop. Is Nodgrun only. Temporalix. Alka. Well, a lot of people are doing Advent code. But the one I'm following is Epsilon 1. Sorry. I think the audio leaked into it. Oh, she's doing it in Perl? Oh, they. Sorry, not she. They. Okay. They still working on the problem? I can't tell. Hold on a second. Let me listen in for a sec. I'll have to mute my audio though. Okay, I can't tell if they're done or not. I need to find someone who is still working on it, not just talking about it. How about Bad Cop? And I have an ad for 30 seconds, but it looks like they're still working on it. So let's rate them. Yep, here we go. Starting the raid. I'll probably be able to do day 10 on time also. So I will see you then. In the meantime, let's go watch someone else work. See ya.